So yeah, my name is Tyler.
I'm Michael.
Colton.
Austin.
Seth.
I'm Grant.
And we are MSOE Senior Design Team OXOC. And we have the fortunate opportunity to work with the NVIDIA GPU firmware team, otherwise called GFW. They tasked us with finding a new solution for their current debugging firmware solution, as their current solution is just a way of just setting some flag registers in their blocks of code that they have and then just running it, and they may be able to see possibly where an error is happening in their code. However, it's just in a big block of code, and it's very difficult to really narrow it down, and they can spend quite a lot of time on this, and it can become very tedious. So they wanted us to create a step-through debugger that is able to set breakpoints, be able to step through line by line, and just really have a full-fledged debugger for UEFI firmware. And we came up with three main goals at the beginning of our term this year. And the main goal was just the UEFI firmware debugging. We had two stretch goals, the first one being GPU microcode debugging, and the second one being early boot graphics. However, we didn't quite reach these, and Colton can tell you a little bit more about that.
Awesome. So if you see the top of the slide, I really believe that senior design was a journey, and I hope that many of you guys feel the same way. It's less of a class and more of an actual engineering project that you're working with a bunch of friends, hopefully, that you can complete and grow over not only with personal skills, but also engineering skills throughout the course of the year. But looking at quarter one, that is when we decided to do a lot of research. That was a lot of the paperwork that we had to do, a lot of looking into IEEE standards and everything. And with that, our team broke up into 3 separate groups, spread ourselves a little thin, and decided to try and research and tackle not only our main goal, but also our 2 reach goals. But with that, we started developing that research with the 3 goals, and then we created a nice development plan that would help us throughout the rest of the year. Moving into quarter 2, we realized that those stretch goals were really unreasonable, and that at the first quarter we kind of stretched ourselves too thin, and we wanted to focus for pretty much the rest of the year specifically on UEFI debug. During this quarter, we fell onto the solution of using an emulated environment for UEFI debug rather than just a hardware development, and with that, we created significant strides in that. And as we were in quarter 2, we discovered that our original ideas wouldn't be as simple as we originally thought, and we discovered some issues along the way. But luckily, we were able to navigate through those issues and make our way to quarter 3, where we were able to design, package, and polish our proof of concept. And then here we are, and we're currently still continuing to research and design hardware proof of concept, but this is where we really fleshed out our emulated environment.
Yeah, so for our main goal of UEFI firmware debug, we initially had 2 main solutions that we wanted to pursue. The first one was actual physical hardware debugging. So how this would have worked is we would have had a target system that was running the NVIDIA GPU, and this would also be what's executing the UEFI firmware. Then we also would have had a host computer that would be running open source software and would be connected to the target system via a physical debug port. And this host system would then be sending commands to the target, allowing us to step through source code, view the contents of memory, and separate points and things like that. So this is what we had planned to do. However, we ran into some issues along the way. First off, we had troubles getting hardware. We were trying to communicate with NVIDIA to get hardware to implement the solution. But throughout the winter and spring quarters, they were going through a pretty busy time. So communication began to slip with them a little bit, and we didn't actually end up getting any hardware. So that was one factor that contributed to this. But another challenge we had was communicating with Intel. Intel develops a proprietary technology called DCI, or Direct Connect Interface, and this would have acted as our physical debug port that we would have connected to on our target system. However, we struggled to get the information we needed from them to actually implement this solution, so ultimately we weren't able to complete physical hardware debugging. So the solution is researched, and we have it documented for further development to continue at NVIDIA. as Austin will talk about later. But as of right now, hardware debugging has not been completed. But Seth will tell you a little bit more about what we actually ended up doing.
Yeah, like Michael said, we were trying to debug the NVIDIA's UEFI drivers on a system connected to another. But in this case, we came upon the solution through the middle of the winter quarter with the idea we were having hardware troubles of emulating the entire system. So that's what we did in this case. We're emulating that UEFI environment fully, and it is preloaded with NVIDIA's UEFI drivers and source code. So with that, we're then able to connect through a virtual debug port with a open source debugger, in this case GDB, and it's using all those same software tools and really that same setup as the hardware debug option. And given that, we are able to, there's no hardware limitations that we were relying on getting and that kind of thing, we were able to develop it in our own time and get it to work. So we have an example here of a simple loop, simple program. You can see we have the terminal there, it's all command line based, but it is a graphical interface, where it says, B for breakpoints at a certain function name. We can put in a function name or a line number, whatever you want, and it will set that breakpoint. And then using S and N for skip and next, you can step over and step into various lines of code like any graphical interface that you're used to. Unfortunately, we can't show you any NVIDIA source code and NVIDIA drivers in this, so we do have just a simple loop that you might have saw flash on the screen, the main code there, but it's just looping through and it's printing out some numbers. But right now it's in print functions and various other things. We're stepping into a handful of different things. But it works just like that.
Yeah, and like I said, once we hit Q2, that's when we really started to find some issues with what we were doing, and the main issues were working within this UEFI development environment. This kind of forced us to, we were not able to sprint, it was more of a crawl throughout the rest of the year, because UEFI is actually relatively new. That being said, there was a severe lack of documentation and an even greater lack of subject matter experts. So we had to find documentation, and we had to discern whether it was outdated or documentation that might not be implemented yet, and we had to kind of sift through files after files after files of documentation to try and find what would work best for us. This made it extremely challenging, but I feel this is where it was the most rewarding. I felt the fact that we had to go through something and teach ourselves something pretty much from the ground up made it a true engineering problem.
So, as Colton mentioned, and as we've mentioned in a few other slides, there were a lot of challenges that we faced throughout this. And with challenges, you can expect mistakes to be made, and in our team's perspective, lessons to be learned. That's kind of how, as a team, we look at making mistakes, is there are opportunities for learning. So I think it's important that at the end of any project, you take some time to reflect on some of those things, just for us as a team, but also because I wanted to share with our fellow peers. In the case that maybe you guys can take something away from this, learn something new from our mistakes, that way you don't have to make them yourselves down the line. So the first lesson that we learned throughout this process is that you can't necessarily tackle every problem you want straight out of the gate. As Colton mentioned, when we started off in the fall, we tried to get our main goal and both of our stretch goals fixed up in a can and ready to go. And this kind of actually set our expectations a little bit higher than they probably should have been. That means that now we're standing up here presenting to you guys about one of our solutions. We were hoping to be able to talk about all three, but that was a mistake that was made along the way. And in addition to that, it also meant that we spent a lot of time focusing on hypotheticals that never manifested themselves in reality. And the consequence of that is that we kind of missed depth in our actual main objective. As a result of that, you can imagine that perhaps if we had focused solely on UEFI debug out of the gate, we might have been a little bit further than we were, or maybe had a little bit more of a refined solution. So yeah, you can't tackle every single problem out of the gate. Lesson 2 is that communication keeps the machine running. As a team, I think that we did a pretty good job in communicating with each other internally and maintaining constant contact and understanding where we were. However, we kind of struggled with communicating with our outside contacts. Specifically, because of the GFW team's constant busyness, we often allowed important meetings with them to slip. And we didn't really provide enough initiative to keep those communication pipelines running. And as a consequence of that, We had a little bit of misalignment on our goals and objectives in the beginning that caused a little bit of confusion and setback. And it also delayed the communication of some very critical ideas. Specifically, my favorite example of this is the emulated debug solution. We didn't think of that until winter quarter swung around. Perhaps if we had had hindsight to look at that in fall quarter, we would have been able to make more progress as well. And finally, this also contributed to our lack of resources. When you don't have the knowledge that you need, you can't do a whole lot. So yeah, communication keeps the machine running. And then of course, the final lesson here is that motivation is fuel. Without it, you're going nowhere. As a team, it's incredibly important to be constantly motivated, constantly running, especially intrinsic motivation. And our team, when we started off the term, we were burning. We were burning through stuff like crazy. However, I think because we set our expectations so high, and because of the general lack of correspondence that we had with our contacts at NVIDIA, it kind of chipped away at our team morale over time. And the end result of that was that our motivation and initiative gradually diminished throughout the year. Not so much that it completely impaired us, but it definitely made it a little bit more challenging to keep going. But yeah, so those are 3 kind of lessons that, I think are really important to look on, and I think that all of us in the future can keep in mind, and hopefully some of you can as well. So with that, I'll hand things over to Austin.
Ooh, sorry. Oh, okay. Thanks, Grant. I'm going to talk a little bit about what our project will look like moving forward, and what some future work that may be done when we pass it over to NVIDIA. So we're talking to our NVIDIA contacts. It's seeming like our particular UE5 debug solution will not be integrated into the graphics firmware team workflow for about 1 to 2 years. This will be when they start working on updating their existing drivers or creating new ones for new products. And so so it'll be a couple years until that happens. Grant and I are actually going to start full-time at NVIDIA starting this summer. And so since we'll be working there, we will likely be the ones to continue development when that time comes. Alongside several NVIDIA subject matter experts, as well as with better access to resources that they have. So what some ideas for what some of these continued goals will look like are: 1, to package our debug tool in a GUI application. This will increase the ease of use of our application and decrease the learning curve for it. Our application right now is all command line based, which is not always the easiest to use. So I figure creating a GUI application for it in the future will allow more and more employees to pick the tool up pretty quickly. Secondly is to explore GPU pass-through to the emulator. This is the feature of the Keynote emulator that allows the hardware to pass the PCI bus to the emulator. Unfortunately, we weren't able to get this working this year. That is just due to lack of compatible hardware that we never were able to get. And lastly, to test and document the DCI hardware portion of our project. So although we did not complete what we set out to at the very beginning of the year, what we have now in its current state is still very valuable to NVIDIA. Given that we worked on our project independent from NVIDIA and that the GFW team has had an incredibly full and busy plate lately, working on the outside of the company saved them valuable time and money. So when they pick it up in the future, they have a strong foundation for which to continue. And this foundation that we created for them is the requirements gathering, the design that we did, and also the implementation of our prototype for them. And we have it packaged nicely for them to continue work in the future. And lastly, UE5 and its debug tools are very powerful and not without their flaws. And the experience that we all have gained throughout this year, working with both the debug tools and just the UE5 environments in general, is very valuable for both our careers and also when we pass it over into NVIDIA to help them kind of get up to speed. And this is because they won't have to work through all the many roadblocks that we encountered throughout the year. Okay, so with that, I would like to give a quick thanks to our Senior Design Advisor, Dr. Durant, and our 3 contacts at NVIDIA, Jim Hambigo, RJ Wright, and John Robb. Okay, and that concludes our presentation. We are now open for any questions.
Yeah.
Yes.
You have a demo of what you did.
Yes, that was the video that Seth played earlier. We can go back to it if you like.
Yeah, can you play that?
Yep.
Let's see if I have to next there. Should be going there.
Yeah, so in the left window here, you'll be able to see the actual source that's running. In the right is the emulated UEFI shell that we're running it in. And of course, it's got the standard DVD command line interface that we use to step through the code there.
Yes, the name of the function that's being, the main function of this program is the test UEFI main. So it's setting a breakpoint, you can see it says the line number exactly. So it's finding the start of that function and stopping there. You can actually see the function right there, that screen that it is running. Very simple, rudimentary, as a proof of concept to show you guys. But yeah, it's stepping into a handful of different functions. One later on, you'll see the loop start to print out on the other side as well. But yeah, they can use this, NVIDIA use this for their drivers. Having a program that calls, the various different commands, you can step into the functions and see exactly what's going on.
Yeah, and also when we get hardware for it, when you can start testing this on hardware, the Kimo emulator can be directly and GDB can be directly translated to go across the DCI cable as opposed to in an emulated environment. So it's pretty much the same exact process. So we weren't able to get access to hardware, but as far as how it works, would be very, very similar.
Yeah, the debugger is connected through a virtual serial port, very similar to that DCI connection.
And the DCI is the Intel technology, which
Correct,
you weren't able to fully work out the details of that.
Yeah, it poses the main reason it poses security risk in a lot of motherboards. So consumer motherboards have it all disabled. They use it to develop their motherboards and that kind of thing. All the Intel CPUs have it enabled, but you need to get either special access or the makers of the motherboards can enable it themselves. So
Michael touched a little bit on our communication challenges with Intel. One of those things is that...
And I'm sorry, please try to use the microphone.
Oh, yes, absolutely. Michael touched earlier on the communication challenges with Intel, and one of the things that we did have challenges with is that we're trying to find specifically motherboards that allow DCI to be exposed. As such, they usually only reveal that information to proprietary partners with, big wallets. So unfortunately, we didn't have those resources available to us.
It's very hard to get it.
Yeah. Any additional questions?
I think we can do one or two more questions. Does anyone have one?
it'd be random off topic.
I have one, but I'm just making sure. Oh, so were there drawbacks to not being able to get the actual hardware debug working? Are there, what I'm getting at is, are there things that QEMU is virtualizing that take away from what the engineer really would want to be debugging?
Yeah, one of the challenges with Kemu or Kemu, I can't remember how to pronounce it. We've pronounced it like 5 different ways. One of the challenges is that you're not able to actually debug on boot. In order to actually, debug the application, you're debugging a UEFI application that makes a call to a loaded driver. In reality, when it's running on hardware, that driver is loaded at boot time and run before a UEFI shell can even get up and running. So that is one of the drawbacks, that in an emulated environment you can't debug it in the exact same context that it's actually going to be running on a machine, but it is fairly simple. We would have to do a little bit more testing and have a little bit more knowledge of how the NVIDIA GPU driver works to dive into specifics on that question, but they're simple.
Yeah, the UEFI handoff will take, when you boot, the GPU stores this firmware, it passes it over to the CPU, and then it can use that when it's booting up the system to display graphics and that kind of thing, until the OS loads, and that takes over. So in that case, yeah, it is loaded, programmatically and all that kind of way, but when we boot into a shell, it is running the same code from memory. However, it's in a different context, which could, who knows, it's not the exact same way, it could cause some issues.
We can do one last question, if anyone has one. Go ahead. Yeah.
So I was interested in your 3 projects in the beginning, and I almost got the sense that your 3 projects were the real projects, and that this the reboot, the stretch goals was added later. So my question is, and this is for other teams that are coming up, any advice on how, when you make your original choice of your goals, do you have any insight into how to better make those choices so that you don't have to come back later and call them stretch?
Unless one of you guys wants to. I was going to say that the big thing I think for us is that the reason we had so much challenge pinning this down is because we had a large team. There's 6 of us, and we didn't have a whole lot of prior experience knowing exactly what the scope of each of these goals was, like how long they would take, how much manpower they would take to figure out. So my advice, I guess, to future teams would just be to make sure you have one really solid goal, like we chose here. We resolved this at the end that was our main goal. Early on it wasn't. It was just one of 3 goals. But it would be to resolve a main goal and focus on that, and then just add those stretch goals on as additional tasks and work with it as you go. And that was kind of our mantra, as we kind of worked with this as we went and resolved our final vision as we went throughout the year. So if that answers your question.
Yeah, I think what I was also trying to get at is, did you get buy-in from NVIDIA on those goals? I mean, if they had said priority 1, 2, 3, would that have been helpful?
Yeah, well, actually, we did at the beginning. So to answer your question, a little bit of a different way, they said, we want, the UEFI firmware debug. And here's a nice to have, and here's something you can do if you get past that and you want to have some fun. And that's these 3. And we put them as our goals because we thought, oh, those are attainable. They're 1, 2, 3. And now we've reframed them again as this was the main goal because of some of those difficulties we've had. We did have to take a step back and reframe them. So yeah, the advice to the rest of the groups, like you're asking, if that is the case, don't be afraid to put them as, a couple stretch goals and meet your main goal and meet all of the stretch goals. We were just ambitious in our framing.
Okay, thank you.
What? No.